Hi everyone, so this is lesson 47. 46 had no video, it was just more practice with the mean value theorem. So pause and do this mean value theorem problem. So for the mean value theorem, we let the derivative, f prime, which is 6x minus 5, we set that equal to the average rate of change. The average rate of change is f of 5 minus f of 2 over 5 minus 2. So 6x minus 5 equals, let's see, f of 5. So that's 25/75 minus 25 plus 1. And then f of 2, so that's 51 minus all over 3. F of 2 is 12 minus 10 plus 1. 3, 47 over 3. Well, that's gross. Alright, so we're going to add 15 over 3. So that's 6x equals 62 over 3. Divide by 6. 62 over 18. Now, does that fall between 2 and 5? Yes, it does. That's 31 over 9, which is like 3 and change, so that's your C value. Okay, so what does it mean for a function to be increasing or decreasing? So when we did like polynomials in Algebra 2, and when you talked about sine and cosine and stuff, we talked about this. So where would this graph be increasing? Well, it's increasing when the slope is positive, right? Those are where it would be increasing. And then decreasing is where it's going down. So based on that, it's increasing where the slope or derivative is positive, and it's decreasing where the slope or derivative is negative. Suppose it has to be continuous and differentiable. So it's increasing when f prime is greater than, or it doesn't say equal to. Our book doesn't say that. So it's just greater than 0. And then when the derivative is less than 0, the original function is decreasing. Now, the different textbooks some of them say greater than or equal to, some of them say just greater than. So actually, however you write it, if you put equal to or not equal to, it doesn't matter. They're both accepted. Okay, so find where this function is increasing and decreasing. So we need the derivative. So take the derivative. 6x squared minus 18x plus 12. And we need to figure out where it's positive. So we're going to set it equal to 0. 6x squared. I'm going to divide by 6. X squared minus 3x plus 2. So x minus 1, x minus 2. So this graph equals 0 at 1 and at 2. So now here's the question. Where is the derivative positive and negative? So what we're going to do is I'm going to make a number line, and I'm going to put my zeros on there. So this is f prime. So I'm just going to plug in numbers on either side. So I'm going to plug in 0. If I plug in 0 into this, the factored answer, 0 minus 1 is a negative times 0 minus 2 is a negative. So that's a positive. So when x is less than 1, it's increasing. 1 to 2, that's say 1.5. If I plug in 1.5 here, I get a positive and a negative. Positive times a negative is a negative. And then I plug in, say, 3. I get a plus times a plus, so a plus. So that means this function is increasing from negative infinity to 1 and 2 to infinity. If you'd rather put I put intervals. If you'd rather put inequalities, you can do that too. X is less than 1, X is greater than 2. And then it's decreasing in this interval from 1 to 2. And that's my answer. So I use the number line to figure out where is it positive. And these are just test numbers. They're not part of the answer. They're just, I'm trying to figure out where is this graph positive, where is it negative. All right, so pause, see how much you can get done. This one is tricky because of the derivative. So we got f prime equals the derivative 2/3 x squared minus 1 to the negative 1/3 times the derivative of the inside. So we are setting this equal to 0, and I got 4x on top, and then 3 times the cubed root of x squared minus 1 on the bottom. So remember, we're finding our critical numbers. So what are our critical numbers? Critical numbers are 0, where the top equals 0. But we also need to check where the denominator equals to 0, plus or minus 1. All right, so I'm going to make my number line. So I've got -1, 0, and 1. So I'm picking numbers on either side. So -2, -1/2, 1/2, and 2. And I'm plugging into the derivative because we want to know, is the derivative positive or negative? So now in the bottom, when I plug in -2 into the bottom, that's a positive. And then plug into the top, it's a negative. So we're negative there. If I plug in -1/2, a -1/2 on the bottom is a negative over a negative on top, so we get a plus. If I plug in 1/2, I get a negative and then a positive, so plus over a minus, so that's a minus. And then when I plug in 2, I get a positive, right? So I'm just plugging in and figuring out, is this thing going to be positive or negative? Now, notice it jumps every other, negative, minus, plus, minus, plus. That doesn't always happen, so be careful. Don't just assume that that's always going to work. Right? So increasing is the interval where oops, what happened? Increasing is where we're positive, so that started at -1, ended at 0, and then started at 1 and went on forever because of the arrows. And then decreasing, -infinity to -1, and 0 to 1. That's the answer. Again, if you want to use inequalities, go for it. I like set notation better. Okay, so if this is the derivative, where would this graph be increasing and decreasing? All right, so remember, the first thing you want to ask yourself, where is f prime equal to 0? Well, we get -3 crosses, so all these points where crosses the x-axis. So -3, -1, 2, and 4. All right, so increasing, where's this thing where's the derivative greater than 0? That's just above the x-axis. So that's from -3 to -1, and then 4 to infinity. Decreasing is where f prime is less than 0, right? This is greater than 0, and then less than 0. So that's -infinity to -3. Now, you have a choice here. I've seen this 2 different ways. I'm going to do it the easy way, and then the second way. -1, where is this below the axes? So all of this. So -1 to 4. However, because of this 2, it's not technically underneath. So sometimes you'll see this written as -infinity to -3, -1 to 2, and then 2 to 4. So it won't include the 2 because the 2, it's like, it's not actually less than. F prime is not actually less than there, it's equal to. So you see it like this, I will accept that. Right? Either way is correct. Okay, last one, little more challenging. Suppose f is a function that is continuous. So this is the derivative. So go through, pause, see if you can figure these out. What is the domain of the derivative? Well, negative infinity. Well, I would say all real numbers except x equals 0 and x equals 2, right? So that's where it's undefined. Because you need to assume arrows. Books don't have those arrows in them for some reason. The critical numbers, so where does this x equals 0? X equals negative 2. X equals 4. But then also, where is this undefined? X equals 0 and x equals 2. So those are also critical numbers. Does f have a horizontal tangent line? Well, where would the derivative equal 0? So that's your 2 and your 4. Vertical tangent lines. Where would we have a vertical tangent line? Well, that's pretty simple. That's just where there's already a vertical tangent line. Because those vertical tangent lines don't change. They stay. Where's their corner? The corner is at 2. Oh, wait. I wrote this wrong. It was negative 2 and 4. 2, because the slope from the left and the slope from the right are different. Where is f increasing? So where is f prime above the x-axis? So I would say negative 2 to 0. And then 0 to 2. 2 to 4. And then decreasing would be negative infinity to negative 2. And then 4 to infinity. So I broke up the increasing. I didn't include this, and I didn't include the 2. And that's it. Homework. All right, have a fabulous day. I'll see you later.